Hi everyone. Today I'm doing a live session on multiplying polynomials, and I'm going to go through the different techniques that the book shows, as well as a technique that the book does not show that I find to be very helpful. So this is essentially section 5.6. And so there are different methods for multiplying polynomials. The first is using the distributive property. If it's a monomial by something else, that's easy. That's the regular distributive property. But if it's something longer, like a binomial or trinomial by another binomial, trinomial, then you have to extend it further. It's like you're distributing twice. We've got the vertical method, which the book demonstrates, which is similar to how you would multiply numbers by hand. And then the tabular method, which is something the book does not demonstrate, which I prefer if I'm multiplying large things. And then we have FOIL, which you can only use if you're multiplying binomials. There are also some shortcuts, but those have to be when your polynomials are in a specific form. So I don't necessarily recommend using those until you get really good with multiplying. So I'm going to start with the distributive property. So the example on the left is the regular distributive property, and then the example on the right is the extended version. So I'm going to go through both of these. So as we know, the distributive properties are just taking that what's on the left, on the outside of the parentheses, and multiplying it by the inside. So you have 5ab times 2ab plus 5ab times 6a plus 5ab times negative 3. And so now this is going back to 5.1 when we're simplifying expressions with exponential expressions. Now here we don't have any exponents, but the rules are the same, where you add. So I have 5ab times 2ab. 5 times 2 is 10. And, oops, I wrote an A, 10. And then the exponents on the a and the b are implied ones. So an a times an a would be a 1 plus 1, so that gives you a squared. And then a b times a b gives you b squared. The next term, I do 5 times 6, which is 30. And then a times a, so that's a squared, and then b. And then I have 5 times negative 3, so that's negative 15. A, and then b times b is b squared. Once you've done the multiplying, then you check to see if you have any like terms. In this case, we don't. So that is as simplified as we can get it. The example on the right here is I've got 5s plus 3 times s squared plus s minus 2. So I'm going to use the extended distributive property by basically multiplying the 5s by the entire second polynomial, s squared plus s minus 2. And then 3 times the entire second polynomial, s squared plus s minus 2. So I have the 5s times the polynomial, and then the 3 times the polynomial. From here, now we use the distributive property. So I have the 5s times s squared plus 5s times s plus 5s times negative 2. Then I have plus 3 times s squared. And when I'm running out of room, I'm going to just go down below. Then it's 3 times s and 3 times negative 2. So we end up with 6 terms here. And you can figure that out. So my 5s plus 3, that has 2 terms. S squared plus s minus 2 is 3 terms. 2 times 3 is 6. So you should get 6 terms when you do the multiplication. And you can see this gets kind of lengthy. So I actually do not prefer doing this method of multiplication, but I am going to show you it so you can see how it works. So now I need to actually do the multiplication. So if it helps, so you can see where each line is, because it is kind of getting confusing there. I'm going to just put a little arrow there since I had to kind of run over. So 5s times s squared. So that s has an implied exponent of 1, so you add those. You get 5s cubed plus, then 5s times s, so that's 5s squared. 5s times negative 2 is going to give you negative 10s. Then I have the 3. 3 times s squared is plus 3s squared. Then 3 times s is 3s. And then 3 times 2 is negative 6. So now I need to find my like terms. I don't have any like terms with the s cubed, but I do with the s squared. So I'm going to just highlight those to remember to add those together. And then I do have like terms with my minus 10s and the 3s. So I'm going to highlight those to remember to add those together. So next line, I have 5s cubed. Now I add my s squareds. 5 plus 3 is 8, so that's plus 8s squared. When you add, you don't touch the exponent. It's when you multiply, you add the exponents. Then in green, negative 10s plus 3s is negative 7s, and then minus 6. And now that is simplified. So that's demonstrating the distributive property and extending that out so that you can multiply something that doesn't have a monomial. The alternate method to multiply something like what I did on the right here is by the vertical method or the table method. So the table method is my preferred way to do it. And on the next slide here, I'm going to do the same type of problem. It's not the same, it's got different numbers, but it's the same format. And I'm going to demonstrate the vertical method and then the tabular method. So that way you can see there's 3 different ways to do this, and you can see which one you prefer. So the way the vertical method works is that you line them up vertically like you would if you're multiplying numbers. So for an example, if I had 24 times 141, if I was to show this and do this multiplication by hand, usually you put the big number on top, and then you put the next one underneath, and you line things up, and then you multiply. And you start with the rightmost number, and then the next one you kind of move from right to left. So we're going to do the same thing here. So on top, I'm going to have the z squared minus 5z plus, I'm actually going to move this over so that I can have room. Z squared minus 5z plus 25. And then underneath, you need to line up your like terms, so z plus 5. So first you take the 5 on the second row and you multiply it by everything on top. So 5 times 25, which is that one. Oh, let's see, 125. I can do that in my head. Then 5 times negative 5z is negative 25z. So I need to write that. And now, because I got a plus 125, I need a plus sign in there. Then 5 times z squared is 5z squared. What's difficult about this is that you're working from right to left, and so it's kind of hard to make sure you've given yourself enough room. Next, z. So I take that z and I multiply by everything. So z times 25 is 25z. So I'm going to put that lined up. And I'm going to just preemptively put a plus sign there. Then z times negative 5z squared. So that's minus 5z squared. And then the z times z squared, that's z cubed. So now that I've lined everything up, now you add going down. So I have z cubed, 5 minus 5 is 0, negative 25 plus 25 is 0, plus 125. So my answer is z cubed plus 125. So that's using the vertical method. On the right here, I'm going to do the same exact problem with using the tabular method. And the way so it's basically you set up a table. I set it up with the longest going across, so that's z squared minus 5z. And then I don't need to put my plus with the 25. It's just assumed plus. And then going down, I have z and I have 5. So this method is very similar to your multiplication tables. So if I just do in color, like you would have a multiplication table and you would multiply going straight across. You would do each row times a column. 1 times 1 is 1, 1 times 2. You know, this would be how you figure out your multiplication tables. So this table method is very similar to that. So if they're the same size polynomial, then it doesn't matter which one's across and which one's going down. But I just make sure that I usually try to put the longest one going across because it seems to save a little bit of space. So now I multiply a row times a column. And what I like about this method is that I know there's going to be 6 things because I've got 6 blanks there. And so that helps me keep track and make sure I don't forget anything. And it also helps me if I go back to check my answers if I have a mistake, because it's a lot easier to see what you multiply together to get to each number. So it's a lot easier with finding your mistakes. So starting with the first row and then the first column, z times z squared, so that is z cubed. Then z times negative 5z is minus 5z squared. And then z times 25 is 25z. Then I take the second row, 5, and I multiply it by the first column. 5 times z squared is 5z squared. 5 times negative 5z is negative 25z. And then 5 times 25, that's 125. So if you're looking at this method, you may notice that our diagonals are like terms. So this doesn't always happen, but when it happens, it's pretty nice. So if the diagonals are like terms, you can usually add those mentally. And so then I just read off the table. Let me make sure I get to my pen. So I have z cubed. And then if I add my diagonal, 5z squared minus 5z squared, that's 0, so I don't need to write it. Negative 25z plus 25z, that's 0, don't need to write it. And then I have plus 125. So I like this method because it takes up less room. It's easy to check for mistakes. And it's just a lot more organized. So that's the tabular method versus the vertical method. You get the same answer either way. It's all about which method works for you. Now, if you have something that is a binomial by a binomial, so this is a special format, binomial times a binomial, you can use something that is called FOIL. And this is where you have 2 terms times 2 terms, and so you're going to get 4 out when you multiply. So FOIL, and I'm going to just do this off to the side, is an acronym. It stands for first, outside, inside, and last. It's about the shape when you're multiplying. So it makes what I call the FOIL face. So if I just look at, if we ignore what we actually have in our binomials and we just look at, we've got 2 sets of parentheses with minus signs in between them. So the first means you multiply the first terms of each set of parentheses. Then you multiply the outsides, then the insides, and then the last terms. And now you can see why I call it a FOIL face, because it actually looks like it's a face. So that's what the FOIL method is. So using the FOIL method on our binomial times a binomial here, I first do 7n times n. So normally I just do that in my head, but I'm going to write it out. Then we have 7n times negative 2. Then negative 11 times n. And then negative 11 times negative 2. So you can see I got 4 terms here. Then I multiply. So my 7n times n is 7n squared. 7n times negative 2, that's going to give me a negative 14n. Then negative 11n, then plus 22. And then the two insides, those add together. I'm going to highlight these. My minus, whoops, wrong color. Minus 14n minus 11n. So the insides here, these add together. So we get 7n squared minus 14 minus 11 is negative 25n. And then plus 22. And this is a special type of problem. Next week when we factor, we're going to be working backwards. We're going to take things that are trinomials, like what I just got as an answer, and work backwards to undo the foiling. So understanding the FOIL method is good because that will help you factor. And you can see that it is essentially just like the extended distributive property. It's just it has an acronym to remember it. That's all. But if you look at the line here with the arrow, that's the same format when I did the distributive property, the extended distributive property. It looks the same. So it's essentially doing that, just has an acronym when you have 2 terms times 2 terms. So doing the same problem with the table method, since these are the same size, it doesn't matter which one goes across and which one goes down. So I'm going to just do 7n minus 11, and then n negative 2. And then I'm going to make my table. And so you can see there's going to be 4 terms when I multiply that out. So row times column, so the first row is n. The first column is 7n. So n times 7n is 7n squared. Then I do n times negative 11, so that's negative 11n. Then second row, negative 2 times 7n is negative 14n. Negative 2 times negative 11 is 22. And just like the other time with the table, our diagonals here are like terms. And so when I write my answer, we've got 7n squared. Then I can combine my diagonals. That gives me negative 25n, then plus 22. Same answer. It's just a different way of organizing it. But if you want to get really good with factoring, I recommend FOIL. So what I recommend people do is that if it's 2 terms times 2 terms, use FOIL. If it's anything bigger, use the table method. That's how I do it. Because that way you can get good at learning how to factor, which is something we do specifically with the 2 terms times 2 terms. We end up going back to that form a lot. And then you can also have the benefit of the table method where it keeps things organized. So I said that there were some special cases, and these are specifically if you're multiplying binomials, 2 terms times 2 terms. And so there's what's called the difference of squares. These are called conjugates because you have the same thing, but they just have opposite signs inside the parentheses. When those multiply out, your middle terms cancel, and you're just left with the first term minus the last term if you're looking at the FOIL. So it's like the O and the I of foiling disappear. Then we have what's called the perfect square trinomial, where you have the same thing and it's squared. So that is basically saying that you have the same thing multiplied by itself. So instead of a plus b squared, that's a plus b times a plus b, and then a minus b times a minus b. And those have this special form. So what I recommend is memorize the difference of squares and what that looks like. But for the perfect square trinomial, I don't recommend that because it's really difficult for people, and I recommend doing the FOIL or the table process. So I recommend that you rewrite it as I did and then doing FOIL rather than using the special case, because unless the special case and the shortcut will come to you with lots of practice. And so It's better to understand how to do it than to try to memorize that. But the difference of squares, that one is easy enough, and a lot of people can see that pattern immediately, that going ahead trying to memorize that one, I would recommend. So here's some examples. So the first one here is x plus 3, x minus 3. So this is the difference of squares, where you've got the same thing, just opposite signs there. So the middle terms cancel out, and this is going to give you x squared, the first terms, and then the last term, 3 times 3, so that's minus 9. If I did the whole thing, and multiplied the whole thing out, if you just did FOIL, you get x squared minus 3x plus 3x minus 9, because the inside and the outside would give you those 3x's, just opposite signs. And so those cancel out. That's how you get x squared minus 9. So I would memorize that format and that shortcut there. Now these next two, these are the ones where I recommend you actually write it twice and then FOIL. So I have a minus 3 times a minus 3. So first I'm going to do a times a, so that gives me a squared. A times negative 3 is negative 3a. Negative 3a times, so that's, we got to repeat. And then negative 3 times negative 3 is plus 9. So what's special about these types of formats is that you're going to get repeats as the inside and the outside terms, the two middle terms here. So minus 3, minus 3. So you combine those, you get a squared minus 6a plus 9. And that repeat, that's why in our formula here we have plus 2 times something. But it's hard to remember that, so I would just FOIL that out. And the same thing if we have x plus y squared. Oops. I'd write x plus y times x plus y. And then x times x is x squared. X times y is xy. Y times x, so that's yx. Y times y is y squared. Now, x, oops, wrong color. xy and yx are like terms. They have the same variables, same combination of exponents. They're just written in an opposite order, but they're still like terms. So this gives me x squared plus 2, and then we usually use alphabetical order. So that would be xy, then plus y squared. So you can multiply these out as you would anything else, and that's what I recommend. But the first case, I recommend recognizing that, getting practice, and seeing how that one's going to multiply out. So if you have any questions on any of these, of course, you are welcome to email me, give me a call. You can send me a chat message. I am available to help you guys out. So hopefully this has been helpful, will be helpful. I recommend definitely spending the time to learn this multiplication stuff, because it will make your life easier when you do factoring. All right, so I look forward to hearing you guys, getting questions from you, and I hope you guys are having a great day.